Hello and welcome to the first video of our FSMQ series. In today's video, we are going to be covering one of the basics of the qualification, binomial expansion. This is a pretty easy topic to start with, comes towards the front of your textbooks, and often comes up in the first 3 questions of any FSMQ paper. Let's start with an introduction to the topic. To understand binomial expansion, you first need to know how Pascal's triangle works. We first take a single one. This is our first row. Then this splits apart into 2 ones. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and this continues forever. If you take a look, every number is the sum of the 2 numbers above it, and we count non-numbers as 0. Let's introduce the indexes of each row. I will show you why you need them in a moment. Now, to expand brackets using binomial expansion, you first need to take a look at its power. This will correspond to the index you want to use. For example, to the power of 2 uses the row 1, 2, 1. Then, write out the base of the expression by decreasing the first power and increasing the second. Finally, multiply each of the terms by the number it represents on Pascal's triangle. Right, let's do some practice questions. So our first question is, write x plus 2 cubed fully. So to start, we're going to write out Pascal's triangle. We're going to start with 1, and then from there branch out 1, 1, 1, 2, 1, and we're going to continue it. If we split this off here, this is the first, this is the second, down here is going to be the third, and that's the one we want because 3 is up here, they match. So we're going to take this, we're going to box it, and from there we write out the base expansion as I stated, x cubed plus x squared 2 plus x 2 squared plus 2 cubed. Then you need to stick these numbers in front. So we've got 1 times, 3 times, 3 times, 1 times, and then you're going to multiply it all together to get x cubed plus 6x squared plus 12x plus 8. And that's your answer. Okay, so here's our second practice question. And in this question, we need to find the term independent of x in the expansion of x plus 4 over x to the 4. Now, independent just means without any x, no x at all. So in this case, it's when x squared times by anything over x squared and they cancel out. That's what independent means. So we start by writing out Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and this is the fourth. So we box it to show this is the one we're using, and then we're going to write out the base expansion, but only to the point where we know these two terms cancel out. So we're going to do x to the 4 times, not times by plus, x to the 3 times by 4 over x plus x to the 2, 4 over x squared. And then we know those are going to cancel out, so we do dot, dot, dot to show that it's continuing on, but we don't care about those. Multiply these by the numbers in Pascal's triangle, and then we write it out fully. So x to the 4, 16x squared, and then 16 times by 6 for 36, and you got 60, add them up, you've got 96, so that's 96, and then the x's cancel out, so there's nothing else, dot, dot, dot. The independent term is this one, so we box it, and we say 96 is your answer. There you go. Okay, so welcome to the 4 segment of the video. For those who don't know, this is the part of the video where I give you 4 questions on all the different aspects of this one section of the content. So in this case, binomial expansion. And they're all different parts of how this could be looked at. So pure, applied, proof, and riddle are going to be the main ones. It's up to you. You can choose one, or you can do all of them if you're feeling mathsy. Just pause the video and have a go, and then come back and I'll give you the answers. Okay, so now here's the pure answer, in which it's a pretty simple expansion, honestly. It's basically the same as what we've been doing before. Pascal's triangle, expand it. Make sure you watch out for the negative. It's negative 160, not positive, because it has the minus in front of it. Coefficient of x cubed just means whatever's in front of the x cubed. Okay, and then here's the applied section. It's a pretty simple, just compare them, expand them out, state that they're the same, and that's it. Just say they're the same. Okay, and then here's the proof section. This is probably the hardest one of the bunch, just because binomial expansion is fine in this case. It's the same as always. However, brackets, you may forget to multiply one out, so just be careful with that. Make sure you group them together okay. And then explaining it's probably the hardest bit. They're the same because binomial expansion just speeds up the process of counting the number of terms. So instead of grouping them all together at the end, it just immediately counts out how many of each. Okay, and then for riddle, it's basically the same as the last one. However, there's no need to expand out the second one because it's already done for you. You just have to state that they're the same and then say they're the same in both instances. So therefore, they do not change, because not changing is just being equal to each other. Thank you for making it to the end of the video. I hope you come for the next one. There's some extra work in the worksheet in the description. There's also space for the 4 math segment on there, just in case you haven't done it yet and you want to have a go at it yourself. Or teachers if you want to give it to your class. Any questions, please comment them in the description and I'll try my best to answer. I'll answer for like the first week and then from then on I'll stop responding, but feel free. Thanks.